When you hear digital transformation, you probably think of really big business process re-engineering projects at an enterprise scale. But we can bring digital transformation back down to reality with augmented reality, making workers' realities better with artificial intelligence, IoT, combined with AR, virtual reality, and other related technologies.
Intelligence is where SAS comes in. For decades, we've been doing data and analytics and artificial intelligence with customers all over the world in most any domain that you can imagine. When we look at extended reality, augmented reality, virtual reality related technologies across domains like retail, healthcare, manufacturing, then what we see is a need for intelligence to make these realities better. We like intelligence in reality. This picture here is a rare case of actually removing some intelligence from reality because it may benefit an invading enemy. It looks like a lot of work. They've got a truck, they've got tools, there's 3 of them. Probably takes a lot of time to go around and remove that intelligence and then of course put it back in later. Wouldn't it be nice if it was digital light, sound, haptics that was driving that intelligence into reality? And even better if we can derive intelligence directly from that reality in real time. IoT does many things. One thing it does is it digitizes reality. Through all of these industrial revolutions, we've had tools and machines and such, but it's only recently that we've had these digital streams. When you think of augmented reality, you can think of it as a user interface onto IoT, being able to see IoT. When you take these realities of workers and you add in digital twins, the digital analog, physical twins, then you get intelligent realities. They could be local or remote, it could be a technician with an augmented reality headset, or it could be a remote expert that's working in real time to help guide that technician. It could certainly be a headset, which we'll talk a lot about today, but it could also be a handheld like a phone or a tablet, or that remote expert could be sitting at their desk. This can be real time, past, as in service reports of an asset, or predictive, what's going to happen with this asset in the future. In all cases, we're trying to make work better by making workers' realities better. Here's an architecture for intelligent realities. On the right side, you have the reality. Presumably you have IoT devices streaming data into the edge, and then you have services from those edge computers. You also have enterprise services and public services that are consumed by these intelligent reality clients. Those clients could be on a toteable like a smartphone or a wearable, such as an augmented reality headset, virtual reality headset, or it could also be ambient, not requiring that the user hold a computer or wear a computer. Spatial augmented reality is a concept of where you use smart projectors and shader labs to be able to project that digital light into the reality. One example would just be to put a red dot where the next bolt should go. Now, OLED monitors could also be really interesting, transparent monitors. In this scene here, the movie set with Charlie Chaplin, then this stunt is not at all as dangerous as it might seem because they have a painting in front of the camera. Now imagine if that was a transparent OLED monitor instead and a person, a worker, was there where the camera is. Then you could augment, without a headset or a smartphone, an entire side of a manufacturing line with real data. Now, obviously, this is not a mobile solution. You can't walk around like this. You have to make assumptions about where the person is. But still, you could be improving reality without having to get into a whole new type of technology. It's also a very IoT approach. You would have to put a lot of stuff together, hook a lot of the stuff up for some kind of custom solution. Now, when you have a device, and this would be a smartphone or a headset, then you are local to some physical reality that you're augmenting. Physical reality isn't the only type of reality. If you're into VR and you put on a VR headset, then what you're going to be seeing is probably a made-up reality. You certainly could have 360-degree video of an actual physical reality, but it's probably a fictional reality. You can also do things in virtual reality, such as fly around real-time commodities market data or social media data. When we're on the virtual reality side of things, then we have this virtual world concept that you would do on a flat screen, whereas virtual reality is something you do in a headset. But as social media has shown us, as apps like Altspace has shown us, that has both a flat screen and a virtual reality interface, then these two are very closely related from the development side. On the augmented reality side, then it might be flat screen and be called augmented reality. So a mobile flat screen like a smartphone, or a monocle. So the Glass Enterprise Edition, as well as products from Vuzix and other products, is essentially just a small screen right in front of one of your eyes, and it's communicating some flat information. Now, as you get into headsets like Lenovo A6, Lenovo A3, HoloLens, Nreal, Magic Leap, then these are mixed reality capable devices, mixed reality devices that are also augmented reality devices, and they can be local or remote. That middle section is where the headsets are, but still it's not a question of having to use a headset. There's still other options to be able to augment reality and do it well. The big difference you get between the flat screens and the headsets is that with the flat screens, you're having to hold the computer, whereas with the headsets, you can be heads up and hands free, like this worker here looking at a jet engine. That's a very powerful thing for a lot of cases. On the far left, you see assisted reality, the concept that you're just providing a little bit of information through that small screen to the worker. And then you have the mixed reality, which kind of ventures into virtual reality territory. You're essentially virtualizing small pieces of reality and then putting them on top of the physical reality. And it's much more powerful. You could actually have a model of a machine running in your augmented reality headset in this way. All of these different concepts, they can be used together. This diagram illustrates fighting an IoT cyber attack with a combination of AR and VR. Those spatial techniques we described earlier, they could also come to play. What holds it all together is the AI and streaming analytics. If you're going to be in the business of augmented reality, you need to get results. Thankfully, ever since the really early days of augmented reality devices, it has been pretty easy to get really good results. And these are just a couple of examples where early POCs have reached really good expectations. Newport News Shipbuilding, 96% reduction in inspection time. Lee Company doing building systems, a 20x ROI on augmented reality investment. These are really good numbers. And as you look across these cases and plenty of other cases that are out there, these are pretty easy to find. A couple themes come up time and time again. You want to reduce time to information. And that's the real story there with the Newport News Shipbuilding. What that's about is putting exactly the right information in front of an inspector so they don't have to go search for it. They don't have to go look it up. Closely related to that is reducing cognitive load. So let's say that you have an Ethernet cable and you need to plug it into a port. Well, which port should it go into? That's a problem that augmented reality might be able to help you with, where it highlights the correct port. In that situation, you're having to think a lot less, you're having to figure a lot less out, and you're having an easier time. Another really strong area across AR and VR is training. Being able to use these technologies to give a whole nother level of training beyond just looking at flat manuals. When you start to take those themes together and the power of being able to bring intelligence into reality, then it becomes apparent that there's more going on here than just trying to be smart, just having a reality that gets an A+ and goes to the front of the class. Where we can go with this intelligence is we use the intelligence to create nurturing realities and empathetic realities, so that the whole reality, all of the assets and all of the people, they're all working together. They're all on the same team, making work better by making workers' realities better. So let's build an intelligent reality. This example architecture is for an AR/VR digital twin solution. You start with an AR device, and in all likelihood, you're going to be connecting via Wi-Fi. And first thing you need to do is you have to identify that asset. You have to be able to look it up, and that is the asset metadata. That's the case of looking up asset metadata. And that might be on the cloud, or it might be on an edge device. Now, one reason you might choose the edge device would be latency. Maybe you just want it to run a little bit more quickly. But the real story here is the ongoing dialogue about information technology versus operational technology. A plant manager and a data center manager view technology in different ways. So a plant manager may be motivated to have that asset lookup occur on an edge device so that the plant can be more independent, so it doesn't have an upstream dependency. Now, as you move into mixed reality, virtual reality, and virtual world, in addition to augmented reality, then you have a need to interject the data, get that intelligence into the reality. And that can be accomplished in several different ways. For ad hoc analytics, historic and predictive data, that's probably going to the cloud. That's kind of a big data problem. But your real-time streaming AI analytics, that could be cloud or edge or both. But there's a really compelling case due to latency of going ahead and processing that data right there at the edge so that you can get it into the headset as quickly as possible. So it's truly a real-time thing. Now, the other part of this, especially as you move into virtual reality or mixed reality applications, is you need to be able to render assets. So if you have that technician on the floor, then maybe they glance away and then they see a working model, they see the inside of the machine, and they can go back and then figure out the right thing to do. And then certainly a remote expert would like to have a rendering of what's going on and have that layered on top of the asset in question. For that, you have a couple different options. One is that you would embed the 3D models into the XR application itself, or you could also have them cached on the edge or get that information from the cloud. Now, the UX of augmented reality is really, really important above and beyond the system architecture. These UIs of augmented reality, that's where the artificial and human intelligence meet. That's the foundation of an intelligent reality. So a couple tips and observations here. With the optical pass-through headsets, like the ones that I just mentioned earlier, these UIs can be ghostly. And that's because you can't achieve opacity when you're looking through a piece of glass that is having light projected against it. That means, for example, that the color black is not in the palette. The color black comes out as transparent. This can be limiting, but you can overcome it. Now, on a hardware side, there is another development out there, and these are video pass-through headsets. Still very early for this kind of technology. What a video pass-through AR headset is it's essentially a VR headset where the cameras of the headset are then creating in real time 3D video of the proximate reality. And then they're displaying that to the user. And you can walk around with these headsets because the reality that is being displayed inside the headset is exactly the reality outside the headset. And once you go with this approach, then you get opacity back and you get the color black back. Flat data visualization, good news is it works. Other kind of flat artifacts, they do work in AR, but you do need to be careful. So one thing that probably wouldn't work is if you have a great dashboard that looks wonderful on your PC in full screen, and you try to bring that into AR, that's probably not going to be successful for a couple of reasons. First off, you're going to overwhelm the reality because you're going to completely fill the field of view with that dashboard, and your user isn't really going to be able to see anything else. Another thing that frequently happens with this kind of approach is that even if you break down the dashboard and you're just bringing in individual charts, then it's possible that you might have some really small text around hash marks and that kind of thing, and then that text may not be readable. So while you may get lucky and be able to bring charts in directly into AR and have them work wonderfully, it's likely that you're going to need to design for the AR charts. Like a smartphone, apps are full screen. You can switch between apps, but there's one app that's effectively running at a time. Very different from a PC where you move between apps and you can have two apps at the same time looking back and forth between them. These are a few kind of high-level tips, but really the UI design is just very different in augmented reality. It's a new kind of computer. User input especially is very limited. And also the problem space. What you really want to do is you want these apps to be expecting much less work from the user and do much work for them in terms of selecting the best content for that user at this moment in time. And as you do that, as you really leverage artificial intelligence to help drive that, because there simply isn't enough human intelligence to go around to design all these intelligent realities, then that's how you're able to get that user experience where you have intelligent realities that are nurturing and empathetic. Thanks for your time today. I have my contact information here. I'd be very interested in hearing from you about what you're doing with augmented reality. And you can also follow up on any of these topics at the SAS website. So good luck, and let's go digitally transform some workers' realities.